A walkthrough of Supplementary Problem 15 of Module 3 in the book Problem Solving Guide for Mechanics and Thermodynamics. We have a 1,000 Newton car moving forward at a speed of 20 meters per second. It's accelerating at 1 meter per second every second. Let's put the acceleration on the diagram. That's also forward. These are not forces, just indicating the direction of the acceleration and the direction of the velocity. The car tire exerted 2,000 Newton force on the road opposite to its direction of motion. Let's put that on there. The car tires are pushing back on the road with a force of 2,000 newtons. Part A, if the car tires exert a 2,000 Newton force on the road opposite the motion of the car, that is backwards, what is the magnitude and direction of the force the road exerts on the tires? This is Newton's second law. Every action produces an equal and opposite reaction. It has to be the opposite direction, same magnitude. So it's 2,000 newtons forward, and that's exactly what this force is right here. This is the force of the road on the tires. So let's put that in. Force of the road on the car. We don't need this anymore. And in fact, since this is an action-reaction pair, equal and opposite, we should put it next to that down there. So there's two forces on the car. The force of the road on the car and the drag force. If we want to figure out the acceleration of the car, we need the forces on the car, not the forces on the road. There's only two forces on the car here, besides the vertical forces of gravity and the normal force. We have the road on the car pushing it forward and the drag force pushing it backwards. So part A, the force of the road on the car must be 2,000 newtons forward. What do we call that force? That's the frictional force. The way the car moves forward is to push backwards on the road to make the road push forward on the car. If the tires are spinning or slipping, then it's the kinetic frictional force. If you're driving normally, it's just the static frictional force. The tires aren't slipping. Part C asks for the drag force. How big is this drag force? Well, we know the net force on the car is ma. There's two forces on the car. The road's pushing forward, the drag force is pushing backwards, and we have ma. It's given. The car has a mass of 1,000 kilograms and an acceleration of 1 meters per second each second. So we can calculate what the net force on the car is. The net force is 1,000 newtons forward. And we know that the force of the road on the car is 2,000 newtons forward. So the drag force must be 1,000 newtons backward to get a net force of 1,000 newtons forward. 2,000 newtons forward right here, 1,000 newtons backward right here. And that's problem 315.